Hello everyone, today our topic of discussion is dealing with negative powers and exponents. From my previous videos, we learned how to deal with normal powers and exponents. So for example, if we had 2 to the power of 4, that would be the same as 1 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So it's 2 multiplied by each other 4 times, and there's always 1 multiplied by anything. So that's the same as 16. Now, when dealing with 2 to the power of negative 4, that would be the same as 1 multiplied by 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2, giving us 1 over 16. Therefore, we can say that 2 to the power of negative 4 or 1 over 16 is the reciprocal of 2 power of 4. Reciprocal meaning, so the reciprocal of 2 is 1 over 2. So when someone asks you like what's the reciprocal of n, for example, it's 1 over n. Okay, so let's move on to some examples so that you can understand the concepts well. Let's solve a few more examples to make sure you understood the concept. So if we have 3 to the power of negative 2, that would be the same as 1 over 3 power of 2, giving us 1 over 9. If you have, this is a fun one, 2 to the power of negative 1, all to the power of negative 1, that would be the same as 1 over 2, all to the power of negative 1. And simplifying this further, you get 1 over 1, all over 1 over 2. And to simplify this, you just multiply the farthest numbers and the closest numbers, and you get 2 over 1, which is 2. So all this was the same as just the 2. Now let's solve a few more. Let's say we have 2 over 3 power of negative 1. That would be the same as 2 over 1 over 3. So to simplify this, we can write it as 2 over 1 all over 1 over 3. We multiply the farthest numbers and the closest numbers. We get 2 times 3 over 1 times 1, which is 1, giving us 2 times 3, 6. Finally, let's solve one more example, which is a bit more difficult, and then we'll move on to some examples you can see in some exams. So, if we have 2 multiplied by 5 to the power of negative 1 all over 3 to the power of negative 1, that would be the same as 2 multiplied by 3 all over 5. So the 5, because it's power of negative 1, it goes to the denominator, and the 3 to the power of negative 1 goes to the numerator, giving us 6 over 5. Okay, so let's solve these examples to get a better idea. So evaluate the following. 2 to the power of negative 1, that's the same as 1 over 2. When dealing with 5 to the power of negative 2, that's the same as 1 over 5 to the power of 2, which is the same as 1 over 25. In the third one, we have 2 over 3 all to the power of negative 1. So what you can do is write 1 over 2 to the power of 1 over 1 over 3 to the power of 1. And to simplify this, you just multiply the furthest numbers and the closest numbers together. You get 3 over 2. Finally, for the fourth one, it's 4 to the power of negative 2, which is the same as 1 over 4 to the power of 2, which is 1 over 16. Moving on to some more exercises. In this question, it's asking us to evaluate the following. And there's a note to remember that when dealing with power to the power, you multiply the powers, as we discussed in our first video. So for the first question, we have 16 power of negative 1. And we have to write it in the form of 4 to the power of something. So we know that 16 is 4 to the power of 2. So we write 4 to the power of 2 all to the power of negative 1. And when dealing with power to the power, we multiply the powers. So we get 4 to the power of 2 multiplied by negative 1, giving us 4 to the power of negative 2. If they hadn't specified that we needed to write it in 4 to the power of something, we could have also written it as 1 over 4 to the power of 2, which is also 1 over 16. But we don't need to do that in this question. So let's go back to 4 to the power of negative 2. Okay, moving on to part 2, we have 25 power of negative 2, and we need to write it in the form of 5 to the power of something. So 25 is 5 to the power of 2. So we write 5 to the power of 2 all to the power of negative 2. Simplify this, we write 5 to the power of 2 multiplied by negative 2, giving us 5 to the power of negative 4. Finally, let's move on to part 3, where we have 9 to the power of negative 5, and we need to write it in the form of 3 to the power of something. 3 to the power of 2 gives us 9. So we write 3 to the power of 2 all to the power of negative 5. And to simplify this, we simply multiply 2 by negative 5, giving us 3 to the power of negative 10. Hopefully you're solving along and you're getting all the answers correctly and you're understanding the concepts. Let me know in the comments below if you have any questions, and let's continue on. So for this section, it's asking us to verify that a over b squared multiplied by a over b all to the power of negative 2 is the same as 1, where a and b cannot be 0. So let's start solving. We have a, which is a over b power of 2 multiplied by a over b power of negative 2. So there's two methods to solve this. Let's start with the first method, where you say that a over b is x, for example. In this case, we have x to the power of 2 multiplied by x power of negative 2. And we already know how to solve this. When you're multiplying two numbers with the same base, you just add the powers. So for this example, we would get x to the power of 2 plus negative 2. So that's the same as 2 minus 2, which is x to the power of 0. So let's substitute x for a over b, giving us a over b power of 0. And we know that anything to the power of 0 is 1. So we prove that a over b squared multiplied by a over b power of negative 2 is equal to 1. Now let's work on the second method, where you have to expand then simplify. So it's a squared over b squared multiplied by a to the power of negative 2 over b to the power of negative 2. A squared over b squared stays the same. So we have a squared over b squared multiplied by a to the power of negative 2 is 1 over a squared. And that's all over b to the power of negative 2, which is the same as 1 over b squared. So to simplify this even further, you multiply the furthest numbers apart and the closest numbers apart, and you'll get a squared over b squared multiplied by b squared over a squared. When simplifying this, the a squared cancels out with the a squared, giving us 1 and 1, and the b squared cancels out with the b squared, giving us 1 and 1, with the final answer being 1. So, using both methods, we were able to prove that a over b squared multiplied by a over b to the power of negative 2 is equal to 1. Now let's move on to part B. Now moving on to B, where we have to deduce the value of 2 over 3 all to the power of 2 multiplied by 3 over 2 all to the power of negative 2. To do this, we have to expand, then simplify. So let's start off with expanding. So it's 2 squared over 3 squared multiplied by 3 power of negative 2 over 2 to the power of negative 2. Simplify this even further, we get 2 squared, which is 4, over 3 squared, 9, multiplied by 3 to the power of negative 2, which is 1 over 9, all over 2 to the power of negative 2, which is 1 over 4. As I said before, when you're simplifying this, you just multiply the furthest numbers apart and the closest, and you'll get 4 over 9 multiplied by 4 over 9, giving us 16 over 81. Hopefully you got the same answer. And this is the end of the video. Please like, subscribe, and comment below if you have any questions or any suggestions for future videos. Thank you for watching, and goodbye.